In this video, we will go through a few examples where we will identify the null and alternative hypothesis and also identify if it's a one-sided or two-sided test. So in each example here, we're given a research question, and we are then going to use that research question to identify the null and alternative hypothesis. So part A, the research question is, does Mr. Young have more than 80% support from registered voters? First of all, notice this is a categorical set of data. We would go out to a set of voters and we would ask them, do you support Mr. Young or not support Mr. Young? So they would fall into one of those two categories. We'd then have a big list saying yes, support, or no, not support, and we would calculate the sample statistic, the percentage of our sample which supported Mr. Young. This 80% here is our questioned value for the population parameter pi. We're asking, is pi equal to 80%? Is the proportion of people in the entire population equal to 80%? So a null hypothesis is always started out by writing H sub 0 colon, which you read as the null hypothesis is as follows. We then follow that up by writing what we are assuming the population parameter is equal to. A null hypothesis always has an equal sign. So in this case, we are going to ask, is pi equal to 0.8? Is the population parameter equal to 80%? In context, this would mean that 80% of registered voters support Mr. Young. Next, we're asked to write the alternative hypothesis, which again is started by writing your capital H sub A and then a colon, which reads, the alternative hypothesis is as follows. The alternative hypothesis will also be a statement about pi. It is sort of like the opposite of the null hypothesis. You'll have one conclusion or the other. At the end of this, you would conclude the null hypothesis is supported or the alternative hypothesis is supported. So we're going to say either pi is equal to 0.8 or, in this case, pi is greater than 0.8. Now, how do I know it's greater? Because the research question is phrased as wondering if Mr. Young has more than 80% support, wondering if pi is more than 0.8. So you get that less than or greater than or not equal to based on the research question. Now in context, it would read as follows. The alternative hypothesis is as follows. More than 80% of registered voters support Mr. Young. Lastly, we're asked to identify if this is a one-sided test or a two-sided test, and this is a one-sided test. If you are having an alternative hypothesis with a less than symbol or an alternative hypothesis with a greater than symbol, that's a one-sided test. The only time you'll have a two-sided test is if you're using that not equal to sign, which is not the case here. Part B, the research question states, is the average length of all the wires less than 4.2 inches? So to write a null hypothesis, we start with H sub 0 colon. In this problem, we're asking about the population parameter mu. Mu is the population mean. So in this problem, we are asking, is the population mean, the mean of all the wires' lengths, equal to 4.2? So that's the null hypothesis, that mu is equal to 4.2. Again, remember, the null hypothesis always contains the equal sign. It's the thing we're going to assume is true as the first step in our hypothesis testing process. So in context, this is read as follows. The null hypothesis is as follows. The average length of all the wires is 4.2 inches. The alternative hypothesis, we start with H sub A and then a colon, and this is going to be the opposite. It's still going to be a statement about mu, but the alternative hypothesis is that mu is less than 4.2 inches. And one of these two is going to be supported when we make the final conclusion. Either mu is equal to 4.2 will seem plausible, or mu less than 4.2 will be supported. How did I say less than? Why do I know that? Because of the research question. The research question is phrased as less than. And here's how we say it in context. The alternative hypothesis is as follows. The average length of all the wires is less than 4.2 inches.